Okay, business algebra, let's continue. Inequalities as functions. If you recall, you may have dealt with inequalities before, but generally inequalities, you graph a line. So in this case, this is y is less than or equal to negative x plus 2 if I move over to the other side. I graph the line y equals negative x plus 2, which will look something like this. And then I shade an entire side, either above or below. In this case, it's less than, so it's below the line. Now, obviously, if I drop a vertical line through this, not only am I going to hit the area once, I'm going to start, once I cross below that line, I'm hitting an infinite number of values, which means inequalities generally are never functions. There are very few that are functions if they result in just the line, but single inequalities are almost never functions unless it's like single points. So if you're ever asked if an inequality is a function, it's just generally no. Now, other things we can do with functions, evaluating functions. So what it means when it says something like f of 2 instead of f of x, let's look at how these compare. Here, we have x's. In the equation, we have x's. Here, the x is replaced with a 2 on the left side, inside the function. So all my x's on the other side of the equation are also going to be replaced with 2. So f of 2 is equal to negative 2 times 2 squared plus 3 times 2 plus 1. That's negative 2 times 4 plus 3 times 2 plus 1, multiply, that's negative 8, plus 6, plus 1, which should be negative 1. So that means f of 2 equals negative 1. When I evaluate the function at 2, an input of 2 gives an output of negative 1. I can evaluate this as fractions as well. This is the absolute value function. Remember, it takes negative values and makes them positive, but it doesn't do anything to positive values. So f of 1/2 equals the absolute value of negative 7 times 1/2 plus 5. That's the absolute value of, when you multiply a whole number by a fraction, you multiply into the numerator, because this is like negative 7 over 1 when you're multiplying across. So this is negative 7/2 plus 5. In order to add a fraction and a whole number, you can make them both fractions. 5 is 10 over 2, the common denominator. Negative 7 plus 10 is 3/2. Now, because this is positive, the absolute value it's already positive. It measures distance, so there's nothing else to do. So f of 1/2 is 3/2. If you evaluate a function at an expression, your answer, instead of being a value, will be an expression. So what does that mean? I'm replacing x with m plus 3, same idea. It's not negative 3 times m plus 3 plus 4. So it's negative 3m when I distribute, minus 9 plus 4, or negative 3m minus 5. You don't need to set it equal to 0 or anything like that. An expression is your answer in this case. Of course, we can do this with even different types of functions. Some square roots, division, same strategy. I'm replacing x with, in this case, 7. So that's the square root of 7 plus 9 over 7 squared plus 2. 7 plus 9 is 16. 7 squared is 49. Square root of 16 is 4, 49 plus 2 is 51. So this is 4 51sts. And one thing this is used for in the future is called the difference quotient. It's this scary looking formula. It's basically the slope between 2 points, only instead of your 2 points being, x1, y1, and x2, y2, it's x and f of x, so the input and output for x, and x plus h and f of x plus h, the input and output for for a certain distance moved to the right, most of the time. Could be to the left. This form has applications in calculus, but let's just look at how it works. So we will use this portion of the formula. We already know f of x according to the problem. It's 10 minus x. H is just going to be h. I just need to find what f of x plus h is relative to this equation. So that means I'm replacing x with x plus h. So instead of 10 minus x, it's now 10 minus x plus h here, which if I distribute the negative is 10 minus x minus h. Now it says I have to take this thing, 10 minus x minus h, and subtract my original, 10 minus x, and divide it by h. So if I distribute here, that's 10 minus x minus h minus 10 plus x, all divided by h. 10 minus 10 will cancel. Negative x plus x also cancels, so the only thing I'm left with is negative h over h, which is negative 1. So that's applying the difference quotient to the function. It's not the hardest, but it is a weird concept in this form. If you have to go into business calculus, which most of you do next semester, then you will encounter the difference quotient again in a different form. It's the basis of most calculus, so it's good to see it now. Now, some kind of functions are special in that they are different at different values of the domain. So we call those a piecewise function. It's different equations over different intervals. And for evaluating it, you need to make sure you're in the right interval. So for example, when it says evaluate this function, f of x is 2x if x is a negative number, or 1/2 x if x is a positive number, a negative number or 0. Evaluate the functions at 3 and negative 7. You ask yourself, is 3 less than or equal to 0, or is 3 greater than 0? 3 is greater than 0, so I'm going to use this function here before the if, and negative 7 is less than 0. So f of 3, I use the second function, which is 1/2 times 3, which is 3/2, or 1/2. For negative 7, though, I don't use that function because it's less than or equal to 0. I use the upper function, which goes with numbers less than or equal to 0, and it's 2 times x. What x in this case is negative 7, so it's negative 14. So the trick is to make sure you're in the right places when you're evaluating. Let's try this again. Now we're evaluating at negative 3, 1, 3, 5, and 10, and we've got 3 different possibilities. So let's start with negative 3. Is it less than 1, less than or equal to 1, between 1 and 5, or greater than or equal to 5? It's less than or equal to 1. Now 1 is our boundary point. You're like, well, I see 1 in 2 places. Which one is it? It's the one that's equal to 1. 3 is between 1 and 5, and 5 is greater than or equal to 5, as is 10. So that tells us which functions we're going to use each time. F of negative 3 is negative 2 times 3 plus 1. That would be negative 6 plus 1, which is negative 5. Plugging in 1 into that first equation as well. Negative 2 times 1 plus 1 is negative 2 plus 1, which is negative 1. 3 is the only one in the middle equation. So f of 3 is 4 times 3 minus 2, or 12 minus 2, which is 10. And 5 and 10 go into the last equation. F of 5 equals 5 plus 2, which is 7. And f of 10 is 10 plus 2, which is 12. So where they are in the domain matters because there are different functions at different times. And this is all for 3.1.